everyone. Today is another series, another episode of the Crash Chemistry series. And then in this episode, we're talking about periodicity. And periodicity basically refers to the process by which different elements in the periodic table experience a gradation in their character and properties from group to group and from period to period. So each of these characters they grade from one to another, one to another. So and then we're going to talk about groups and period, and we're going to talk about properties of the periodic table. So let's get started. So today we are going to talk about groups. And what's a group? A group is basically a vertical region of the periodic table. Now, if you've not seen a periodic table, you can check your chemistry textbook. It's often in chemistry textbooks. So when you check it, you can see that a vertical array of elements is called a group. Then a horizontal array of elements is called a period. So basically, when you have a group and a period, they form your periodic table. Now, after doing that, after forming your periodic table, there are different properties of your periodic table. But before we do that, let's define a group. A group is a vertical array of elements, and there are properties of members of a group. And a group, basically, you can define it based on their properties. In that, members of a group always have the same valence electrons, the same number of valence electrons. So, example of elements in group, there are different groups. There are 8 groups and 7 periods in the periodic table. Now we have group 1 to 8. Then we have period 1 to 7, and then in between group 2 and group 3 we have group 2b, which are the transition elements, and then we have those lanthanides and actinides below the groups. So basically, let's continue. Those groups, example of groups is group 1. So these groups they have their own specific names. For example, elements in group 1 they are called alkali metals, and then elements in group 2 are called alkali earth metals. Elements in group 3 are known as the boron family. Elements in group 4 are known as the carbon family. Elements in group 5 are known as the nitrogen family. Elements in group 6 are known as the oxygen family, and so on and so forth. Elements in group 7 are the chlorine family. So or they are also known as the halogens. The elements in group 8 are generally known as the noble gases. So and then those groups they are kind of up and down vertical arrays from left to right. So and then having talked about group, next we'll talk about periods. A period is basically a group of atoms on a horizontal array. So we have the periods on top of each other. So the period 1 is on top of period 2, which is on top of period 3, which is also on top of period 4, and so on and so forth. So now these periods they have a unique property in that they are horizontal array of elements, and in addition to that, they always have the same number of electron shares. They always have the same number of electron shares. For example, when we have atoms in the same period, for example, something like when we have lithium and beryllium. Lithium and beryllium are both in group 1 and group 2. Lithium, then we have beryllium. So lithium has lithium is lithium. That's 3/7. That's 3/7. Beryllium has 4/9. These are the basically electronic configuration. So yeah. Yes. So now these lithium and beryllium that I'm talking about here, they belong to the same period in the sense that they can be found in the same horizontal array of atoms. But lithium and something like lithium and let's say lithium and sodium, they are found in a vertical array, so they belong to the same group. So that is how group and period works in the periodic table. Now from group 1 to group 8, they have their own different properties. For example, elements in group 1 they are often very electropositive, highly electropositive, and they are all metals. So elements in group 1 include lithium, sodium, francium, cesium, and potassium. So those are elements in group 1. We have elements in group 2, which are beryllium, magnesium, calcium, strontium, barium, and so on and so forth. So those are elements in group 2. And then we have elements in group 3. Elements in group 3 include aluminium and boron. That's also known as the boron family. Elements in group 4 include carbon and silicon. That's the carbon family. Then elements in group 5 include nitrogen, phosphorus. That's the nitrogen family. And then elements in group 6 include oxygen, sulfur. So all those oxygen and sulfur, they are the group 6 or the oxygen family. Then group 7, elements in group 7 include fluorine, chlorine, bromine, iodine, astatine, etc. So and these all these elements in group 7, they are also known as the halogen family, in that they are often producing salts. So the meaning of halogen means salt producer. So this element in group 7, they often combine with electropositive elements to form salt. And take note here that group 7 elements are highly electronegative. So and it is in group 7 you will see the most electronegative element, which is fluorine. Now that fluorine has an electronegativity value of 4.0. Then the least electronegative element is francium, which is also in group 1, but the most electronegative is fluorine in group 7. So then moving on to group 8. Group 8 is consisting of noble gases, and those noble gases, they are called noble gases or inert gases because they do not react very under normal conditions. Example are helium, neon, argon, xenon, radon, and so on and so forth. So those are noble gases. So that's the group. And then for the each period is having elements with same electron shells, as I said earlier. Then let's talk about properties of the periodic table. There are several properties of periodic table we can talk about. We can talk about electropositivity, and basically electropositivity simply means the ability of an element to, it is like the opposite of electronegativity. Is the ability of an element to want to give away its electrons. So basically that is electropositivity. When the stronger the need of the atom or element to give away electrons, the more the electropositivity. And the opposite of electropositivity is known as electronegativity. Basically, that means the ability of the tendency and the power of the atom or element to attract electrons to itself. That's called electronegativity. We also have what's called as electron affinity. Electron affinity is basically the amount of energy released when one mole of gaseous atom is converted to gaseous ion, and that energy is known as electron affinity. And then we have which is, yes, that's electron affinity. Then ionization energy, because electron affinity involves the energy which is given off actually. Then ionization energy is basically the energy that is required for an atom to lose one of its electrons. So that is called ionization potential or ionization value. So this ionization potential, they have different classes of ionization potential. We have first ionization energy or potential, second ionization, and third. So as you move from first to the second to the third, your energy increases because it becomes much more harder for the atom to lose electrons. And then we also have other different properties of the periodic table, like atomic radius, which is the distance between two covalently bonded atoms. For example, if you have an oxygen covalently bonded to another oxygen, then the distance between the nuclei of these two oxygen atoms, when it's divided by 2, is known as the atomic radius. And then the ionic radius involves the distance between the nuclei of two ionically bonded atoms. So that is, so those those atoms will be the same. So for example, for when we are looking for the atomic radius of oxygen, it is the distance between the nuclei of two similar oxygen atoms, and so on and so forth. So that is the atomic radius, and also ionic radius. So but ionic radius involves ions, so and so on and so forth. So basically, let's move on to we have the progress of these properties of the periodic table. For example, the electropositivity increases down the group and decreases across the period. So basically, the electronegativity increases as you go down the group form. For example, in group 1, when you go from lithium to potassium, so the electropositivity increases with when you go down the group, but the electropositivity decreases when you go across from left to right across the period. But other ones that increase down the group is atomic radius and ionic radius. But electronegativity, electron affinity, and ionization potential, those three I mentioned, they decrease down the group and increase across the period. So this is something you can read up in your textbook and understand better. So this video is just meant to be a guide to give you the overview of periodicity of atoms. So basically, we'll talk about groups and periods, and thank you for watching.